I want to tell you that Python 3.10 is not, there was this party, and Pablo Galindo, he was the release manager for this version of Python 3.10. And it's very interesting if you don't work already in the industry, but you want to understand how is like Python release, such a big releases that happen in Python, that you can see the cycle of a release, for example, that it has the first release, the beta, the RC, the production, and you can try out already. Like each release, you can already download and try in your own code. So it's pretty cool. And also, yeah, not everything is a party. Actually, if you commit to be a release manager in an open source project such as Python, you will be with this responsibility for the next 5 years. So you actually have to patch things and continue working. I have 3 microphones. But yeah, I will continue talking. So in Python 3.10, there were breaking changes because we are moving from the version 3.9.7, I think, yes, to the Python 3.10, which is 2 digital minor version. And you cannot see how many things break it in such a big change. And there was someone just commenting about that she was seeing a lot of breaking changes. But I want to tell you, is that worth it? Why? Because in Python 3.10, there were even such small things such as better error messages, more meaningful messages when you have a mistake in your code. And there's actually, it was something that it was missing in Python for a long time because the error messages were not automated. And in the Python 3.10, they actually had a big work to automate those messages. And you can see it here that people really like it. And it actually helps, for example, if you are a beginner in Python, and the first thing you see is like a message saying that there is an error in your code and you don't understand why, it can be frustrating. But now actually Python kind of guides you and tells, okay, the wrong is here, try out this, maybe you had this, and so on. So it's really exciting. And I noticed that Python 3.10 was released last year in October, I believe, 3rd of October. And until now, actually, we already have more than half of the top packages already updated with Python 3.10. So that's really nice to see that it went so fast. And this is less than a year. But if you are a maintainer in a Python, you actually can see if you can actually update. So watch out for that. You can also find the statistic here in PyReadiness. And I must tell you, a lot of people ask me if my Py was already supporting Python 3.10, especially pattern matching. And the answer is yes. They start support like in March, they add some support for pattern matching. So you can try out, you actually have to specify the typings before you actually use and to try to see the exhaustion of your matching. These are the documentation. So this talk is based in this documentation. It's really cool because they had a tutorial only for pattern matching. So you can find all the examples there, and actually, if you don't know anything, you can always ask on Twitter. For some reason, the Python core developers, they always answer, especially for Python 3.10. So what is new in Python 3.10? I already mentioned there was better error messages, and there was also pattern matching, but there were other features such as the context manager, that now you can group it in the parentheses, and the type union operator. So Pablo Galindo, he asked what people like the most. Actually, they like the most beta error messages. I think it would give a great talk, but we're going to be talking about pattern matching. And I hope you are interested. So what's pattern matching? I don't know if you know what's pattern matching in computer science, but it means whether it will or it will not be a match. So it must match something exactly. So it's different from, example, a dating application, because there you can have so many matches, but it does not mean you have a match, I want to tell you. And also is different from pattern recognition, because in pattern recognition, what your algorithm is trying to do is actually to recognize some image, for example, in some special threshold. So for example, if the image looks like 90%, so yeah, it would be like a yes, it would be a cat, for example. So it's a bit different. But in pattern matching, and also how we see it in the Python feature, is actually it will or it will not be a match. So, did we already had pattern matching in Python 3.10? What do you think? There is an example here. The answer is yes. We did have pattern matching in Python 3.10. We had, for example, if you assign x to equals 1 and 2, actually Python is smart enough to assign x to 1 and y to 2. So this is already some sort of pattern matching. And if you think about, for example, when we are dealing with exceptions, we already have something similar to pattern matching. When you try something and it doesn't work, you try to catch the exceptions in each of these statements. So you try to catch the exception, and you can even catch a broader exception. So this is already sort of pattern matching, but pattern matching is more than that. That's what I want to tell you today. So, does anyone here plays games? Okay, he plays, he already told me, he'll play with me. But yeah, if you don't play, there's no problem. But for some reason, when I was doing some interviews and I was interviewing, I noticed that my coworkers always ask people if they play video game. For some reason, they always wanted someone also to play video game with them after work. So yeah, I actually don't play so much, but we're gonna be using a game to understand how pattern matching works. And this game, unfortunately, I only know the name in German. I also don't know in Portuguese, which is my mother tongue. I don't know in Italian as well. But it says Steck Spielzeugen. And it means you are trying to match each of this form and one of these forms here. So for example, if you have a triangle and you try to match the triangle, it won't fit where the triangle is. Well, this is how the game is supposed to be. And this is also how pattern matching is, because once that you have some sort of thing that you want to match, actually you need to try to find which one works, which one actually is the match. So let's see like a simple example. You have it here a form called triangle, and you go into the match, and the variable is called form, so it's the variable that we're gonna be looking for, and we're gonna go for cases. And in this case, we do have a case triangle, which the match works. And we have here something called wildcard. Is when nothing else works, I can also use a wildcard to catch this, to do something there. Actually, you cannot bind anything in the wildcard. If you try to bind something in the wildcard, it will give an exception. But not only that, you can also, actually I have it here, like the name is, because then you can understand the tutorial. For example, pattern. So the pattern is what we are, let me see, oh, yeah, the pattern is what we are gonna looking for, okay, what's the pattern matching that we want to match? And the subject is the thing that we're gonna try to match with the patterns. And we have also the wildcard. So the wildcard should always go in the end if you use it. If you don't use it, nothing really happens. You just, yeah, nothing happens with when you try to match. And here, you can actually see the syntax. So we have here a match of a subject, and then you try to see in every case. And if the subject is equals to some pattern, we're gonna execute it. If not, we're gonna continue looking for some match. Yes, this is funny. But yeah, it could happen that you don't find any match, and then nothing really happens with your code. It's gonna, yeah, give you none in the end. And something to not do it. This is like, I was just trying out, don't ask me why, but if you put the wildcard in the beginning, it will give you a syntax error. And this also gives you like an insight how pattern matching actually is, how you should think about pattern matching. You should never put the broader cases in the beginning. And this shows with the wildcard, for example, because it's so broad, that would mean like we open up the box and everything can come inside. So it's actually not what you want. So you should always think in some sort of triangle where the specific cases go first and you go to the broad ones. Here is an example using pattern matching, an example not using pattern matching. Let me see. So the first one is, you can see it here, that we have a list of elements and we're gonna be doing the match here. And you can see that it's very clear that, for example, we are matching with lists, and we are, for example, in the second one, we expect for the match that this list has 2 elements. And the second element can be anything. But I also, something cool is that I can bind it to a variable called, for example, object. You should be using the word bind and not assign, because of technical reasons. You cannot use this variable outside the pattern matching here. You can only use inside. But yeah, we would be binding to object, and we could use inside the statement. If you try to do that without pattern matching, it comes to be, it's more verbose. And you can see here, I have to check this, for example, the size, the length of the list. I have to go to the index and check the elements. If you work with a list and you try to access index, sometimes it goes wrong, most times it goes wrong. So it's very verbose and it's harder to see it actually. For me, I would prefer the first one with pattern matching, because in this way, you see that's much more clear. You are matching with a list. In the second one, you expect 2 elements of the list. If nothing happens, you would go to the wildcard. And this one is with the if-else. What I want to tell you is that pattern matching is not something new. Most of the things you could do it without pattern matching. You could use if, else, and so on and so forth. But it's more clear, and it definitely, visually, it will help you to write better code. And I'm sure your future self would thank you for writing with pattern matching. Here I have another, actually I timed out that code and I try to see which one is fast, and you can see it here. With pattern matching is slightly fast, but I didn't exhaust here. So in this one, I actually tried to exhaust the pattern match, which means that it didn't find any match, so it goes over all the cases, and also with if else, and it's much faster. I would say 1.7, maybe faster. So it worth maybe because I had to assign things there. I have to check like the size of the variable. So this maybe takes a bit more. But also it's hard to say, because in Python 3.10 there were more things. It's not only pattern matching, but it's optimized for other things. So yeah, I would still say give it a try and try to see with pattern matching. You can always benchmark and see it. There is also here, I put one with and without the pattern matching. In this case, I actually prefer the equal statement, because for 2 reasons. Pattern match is still too young, and with the equal statement, you actually is more explicit. And we have the saying in Python that explicit is better than implicit. Okay, someone knows about Python. And yes, so I would prefer the other one. There is something cool. We have the guard. No, it's not a guard. It's like, to be honest, it's just like a conditional that actually, for example, when you go into the cases, first the condition is checked, and then you can do the matching. So it's similar to what I think listed comprehensions have similar syntax, where the condition is checked first, and then it has something else to it. So in this case, for example, if element is in exists list, then it would check if the match is the match. So it's quite interesting now, because you see it that the level of complexity is growing. -2 minutes? No. I don't think I will make it. Now I'll be fast. There is something called composable pattern matchings, which is when you have actually directions. For example, you have the top, the left, the right, and the bottom. Let's suppose like this. And you don't know from which direction the element is coming. So anything can work there. So for example, this is what you would see it here. you would see that here I actually don't know what's the second one, but I don't care. I can do a pattern matching inside the pattern matching. And this is called composable pattern matching. So it's very powerful because actually you can build things much more complex in this case. And you see here that I don't care what is the second one, and I can still catch that and assign to sides and use it. So it's really interesting. I will just say one more. So you can also match with objects. So when you are matching with objects, the cool thing is that you don't need to go over all the attributes there to find the match. You can just access the ones that you are interested to match, and you will see that, yeah, it's quite useful. What happens in the back of this code is actually checking if it's an instance of an instance, and is doing the pattern matching with the attribute. And you can do the same with dictionaries. I will not have time to show you today, but if you work with dictionaries, you actually can pattern match only in the keys that you are interested. So it's really helpful, because if you have big dictionaries, you don't want to copy every dictionary every time or access them. Having just the thing that you care, it will make your life much easier. Yes, I will just go over it because our time is over, so we won't have time to see this example, which is fine. Yeah. I will give you the slides. But actually, there was some like cool things that I noticed, that there are some like trickies in Python 3.10 that you want. I think it will be a bug in someone's code. For example, here I tried to match with an empty string, and it matched. And actually the explanation behind that is that it's checking first if it's an instance of. Especially, it's only for dictionaries and for classes, objects of classes. It's actually check first if it's an instance. And if it's not, then yeah, if it is already, it will match. That's the reason. But yeah, anyway, I don't have time, and I hope you enjoyed. It was really fast. I had a lot of technical problems, and yes. But you can find these slides in here in this QR code. It's also in my Twitter account. I did a thread explaining pattern matching, which I didn't have the time to explain today. Thank you so much.
Thank you, Laysa. So there is a question here for you. Is it possible to replace multiple if-else branches with match if you're trying, for example, to check if a string starts with X?
Did you ask the question Stack Overflow? This was the example. I can show you, because this is exactly the example that I want to show you. It's like, yes, you can actually check things like this, for example. You can combine with things that Python has, and you can put in the guard, for example, and you can check. Yes, the answer is yes. And you can use pattern matching any if else that you have it in your code. But I don't know if it will fit. You need to try to understand.
All right. There's no other question on Slido. Does anybody else have a question among the crowd? Oh, good.
Why wasn't it there before?
I can answer you, but I don't know. Actually, I think it was. I don't know the reason why it was not there before, but I can tell you that actually it's good that it's there now, because we have other languages that we could get inspiration from and get the best of it. And I did notice that it's much better, for example, what they do in C with matching the switch case. And for example, I think it's more related, even more close to what Rust have, which is a very new language, than old languages. So yeah, I cannot tell you, but I think it's good. Otherwise, I wouldn't have a talk.
All right. Is there any other question? Oh, good.
Hi, great talk. Can you match parts of the strings or get substrings?
you would be actually matching with the string, in the string, and yeah, I think if you put some logic in the if statement, it's possible. Also, something interesting, you can also use args and keywords with pattern matching. That's something that I didn't show because I think it's a bit more advanced, but you can try out. Actually, you can also try out only in IPython. You just download Python 3.10 and yeah, you'll see it. I try out a lot, and every time I try out something weird, I post on my Twitter.
Hey, so I hear many times that pattern matching is a lot more than the switch case in C++. So what is the main great thing about pattern matching on top over that?
Yeah, what is more interesting is that, for example, there's matching with an object. We don't have that in switch case, as far as I know. And matching with the dictionary, in this case, we don't really have that. So it has more things advanced, I would say, that makes easier to write. I think there is, yeah, it's very limited. That's why I think I compare more pattern matching with what Rust has matching, than with what C.
All right, we only have about 20 minutes left, so 20 seconds left. So, so we won't be able to take any other question. Thank you so much, Laysa.